Hello students, this is Mr. Parseghian, and today we are going to discuss the wave and particle nature of light. If you turn off the lights in your bedroom but leave the lights in the hallway on, you can see light shining into your bedroom, even if there isn't a light directly shining in through the doorway. This is because light has the ability to bend around a corner. In looking at the animation, we have a piston that moves back and forth in a small pool of water to create small waves. In the middle, you can see a barrier with an opening that the waves can pass through. Notice how the waves do not only pass straight through the barrier, but in fact bend around the corner. This bending of light and waves around a corner is referred to as diffraction and is evidence that light behaves like a wave. In this demonstration, we are passing laser light through two narrow openings. You can see that as the laser light interacts with itself through the two openings, a pattern of light and dark spots are formed. Light, dark, light, dark, light, dark, light, dark, light. In this animation, two nodes tap the water in the wave pool in order to create circular waves similar to dropping a pebble in a pond. The circular waves interact with each other in much the same way as the laser light interacts with itself, creating an intermittent pattern of waves and calm water. This interaction that both light and waves experience is referred to as interference. Interference is a second piece of evidence that light behaves like a wave. Diffraction and interference are both pieces of evidence that demonstrate light behaves like a wave. While light is not actually a wave, it does exhibit wave-like properties. In this animation, we are shining light on a metal plate in an attempt to provide enough energy to remove electrons from the metal plate. As you can see, low-frequency light, such as red light, does not have the needed energy to remove electrons from the metal. However, as we increase the frequency of the light that we shine on the metal surface, more and more electrons are ejected from the metal surface. We can think of the different frequencies of light as particles. Red light is a smaller particle and doesn't have the minimum energy to remove the electrons, while blue light is a large enough particle to eject electrons. We call these particles photons. Photons are a bundle of energy that is proportional to the frequency of the light. Think of the red light as a ping pong ball. Regardless of how many ping pong balls you throw at a concrete wall, they will not dent the wall. Think of blue light as a bowling ball. Every bowling ball you throw at the concrete wall will take a chip out of the wall. Photons are evidence that light behaves like a particle. While light is neither a wave nor a particle, it has characteristics of both. We call this the dual nature of light.